An autotransformer has a coil winding with a total number of turns between C and D of 200. That is, NDC is 200. It has a tap at A such that NAC is equal to 100 turns, and another tap at B such that NBA is equal to 50 turns. Our task in this problem is to calculate the currents in the various parts of the circuit and show their directions when a 400 volt supply is connected across terminals A to C and two resistive loads, 60 ohms and 40 ohms, are connected across BC and DC respectively. First, let us calculate the voltages applied across the loads, remembering the fact that the supply voltage across AC is 400 volts. Since the number of turns between AC and AC is equal to 100, that means the voltage per turn is 400 divided by 100, and that is equal to 4 volts per turn. The voltage across the 40 ohm load is equal to NDC times the voltage per turn, which is equal to 200 times 4, which is equal to 800 volts. So, according to Ohm's law, the current through the 40 ohm resistor is 800 divided by 40, and that is 20 amps. The voltage across the 60 ohm load is NBC times the voltage per turn, which is 150 times 4, or 600 volts. So the current through the 60 ohm resistor is 600 divided by 60, which is equal to 10 amps, again according to Ohm's law. In order to calculate the supply current, we start by calculating the VA input, and the VA input must equal the VA at the output, which we can calculate from the current through and the voltage drops associated with our loads, which is the VA drawn by the 60 ohm resistor plus the VA drawn by the 40 ohm resistor. Substituting the actual values, we get 600 times 10 plus 800 times 20, which equals 22 kVA. Therefore, the supply current can be calculated by dividing the VA in by the voltage, or 22 kVA divided by 400, which equals 55 amps. Applying Kirchhoff's current law at B, the current in the coil AB is made up of the sum of the currents flowing through the 60 ohm resistor and the current flowing into the 40 ohm resistor, which is 20 plus 10, or 30 amps. Applying Kirchhoff's current law at A, the current in the coil AC is made up of the supply current flowing in minus the current flowing out into the loads, 30 amps, which gives us 55 minus 30, or 25 amps. Ready to go beyond just solving problems? If you've been following my daily post and enjoying the sample problems, you're going to love this. All of these problem sets and more are now available, or soon will be, on my official course site, my Standstore for Electrical Training. Just go to the web address that you see at the bottom of this slide, https://stand.store/GVB. In recent years, the reality of climate change has become impossible to ignore. Severe weather events are growing more frequent and more intense. For homeowners, this means that utility power outages are no longer inconveniences. They can last for hours, days, or in extreme cases, even longer. The question is no longer if, but when. You'll need a solution to keep your homes powered and your family safe. Now is the time to prepare and ensure that you're not left in the dark when the next storm hits. Here are some trusted resources to help you prevent power outages at home. Jackery Canada at this web address, Jackery USA at this web address, Bluetti Canada at this web address, Bluetti USA at this web address, and Bluetti Australia at this web address. And finally, you can get EcoFlow at this web address.